Hey, have you ever wondered why an arcade stick works so well? It's all about the PCB design. Today, I'm going to tell you how PCB design is a skill every electrical engineer should master, even if you're not building arcade sticks. You might think PCB design is just for specialists if you're an electrical engineer, but let me show you why every EE, no matter what your focus, should know this essential skill of PCB design. Hey everyone, I'm TechEd Kirsch, an electrical and electronics engineer and PCB design expert. And today I'm playing some Street Fighter 6 while talking about something every electrical engineer needs to know, and that is PCB design. Now you might be wondering, why should I care about PCB design if I'm not into hardware? Well, by the end of this video, you'll see how understanding PCBs can level up your electrical engineering skills no matter what subfield or subdiscipline in EE you're in. So what exactly is a PCB design? A printed circuit board, or PCB, is a thin board like what you see on my screen here. It's this green board that holds and connects all the electronic components in your devices. So we're looking inside of an arcade stick. This is a do-it-yourself arcade stick with the buttons, just like my arcade stick here that has the buttons on the front, and it has an enclosure, and it will look similar to what you see in here. These are wires, components, and everything, and the printed circuit board is on the lower right in that green board, and you have another PCB up in the upper left and the lower left. Okay, so this has multiple PCBs, but this is what a PCB looks like. Think of the PCB as the backbone of all electronic devices. It physically supports the components, the electronic components that creates the necessary electrical connections between them. So whether it is your gaming controller, gamepad here, if you crack this open, it'll have the PCB. Whether it's your mouse, it has a printed circuit board in there. Any electronic device, your computer, your laptop power supply that I can't bring into view, your laptop, your computer motherboard, this microphone that I'm using, every one of these devices has a printed circuit board. Okay, so I want you to stick around to the end of this video because I'm going to explain my top three reasons why every EE should know printed circuit board design. Okay, we're going to jump right into it. Reason number one, you gain a practical understanding of electronics. Okay, so first off, understanding PCB design gives you a solid foundation in electronics from a practical perspective. Look at what my screen shows here. Like, this is typically what you'll see in a circuits class, right? I used to teach circuits class and labs and everything in undergraduate, and all of this is all fine and dandy, but it didn't really make sense to me when I actually had to look at electronic components for the first time on a breadboard. I was like, what is going on here? So in concept, in theory, I kind of understood what was going on in electronics, but it wasn't until I had to apply the theory with real devices that I really needed to understand the electronic foundations, and I knew whether I understood those things or not. So it's not just about knowing circuits and circuit theory, it's really about understanding how those circuits come to life in a real world product. Okay, just like the controller I'm using right now, the printed circuit board brings the real world components that you learn in circuit theory, like diodes, MOSFETs, resistors, capacitors, into the practical and real world, and they do behave a bit differently, especially the capacitor voltages, depending on things like electromagnetic compatibility, EMI, electromagnetic interference, and all that, signal integrity. And then you have to go back into your Maxwell's equations a little bit, into your electromagnetic field theory. Okay, so when it comes to printed circuit boards, you go from just the theoretical aspects of electrical and electronics engineering to the practical side as well. You'll be able to open up your gaming controller, or open up a TV that had a capacitor blown or something, and be able to analyze what might have gone wrong with the circuit once you're able to design the printed circuit board, because you understand how the real components work in the real world. And you'd also be able to select components in case you need to replace them. So you're basically not only just a double E with theoretical head knowledge about electronics, but practical technician experience as well. Okay, so that's one of the reasons. That's the first reason why I recommend PCB design knowledge, a practical understanding of electronics. And if you want a book to understand that, I recommend the book Practical Electronics for Inventors. Highly recommended book. Okay, so I went ahead and paused the game because I was losing too many times and I need to focus. All right, so reason number 2 is your problem solving skills improve. PCB design sharpens your problem solving skills and you learn to think critically about how components like the ones I have on the screen here, or DigiKey, like how they interact and how to troubleshoot issues with them, even at the design and the schematic phase. Just like analyzing your opponent's moves in Street Fighter to find a weakness, so I can actually stop losing in the game. Anyway, but yeah, the skills that you add on here are things like finding components in DigiKey, Mauser, right? How to do parametric searches, how to look for active components, take into consideration part and component availability, tolerances, rated voltages, operating temperatures, package and casing, why that's important, dimensions, thicknesses, right? Availability, CAD modeling, all right? Speaking of CAD modeling, let's check out Fusion 360. I had to learn how to do 3D models in Fusion 360 and Autodesk Inventor to be able to work with one of my clients in the past. All right, very good client, and paid me decently, handsomely, well, not handsomely, but fairly, very fairly for the work I was doing. And it was just really satisfying to be able to deliver what he was looking for, because I developed a little bit of Autodesk Inventor experience, and then eventually I went to Fusion 360. So you have your printed circuit board that would go into like a fidget spinner. This is Fusion 360. Yeah, so being able to 3D model and then do simulation, static stress and everything. Not saying you have to become a full mechanical CAD engineer or anything like that, but it comes in handy. So that's another skill that I picked up that I can keep in the back pocket. I have it in the back pocket. Another thing is circuit simulation. So a lot of power supplies, I can't show it to you here, but like your laptop power supply, think about that, uses the flyback converter, and you need to do power electronic simulation. So I was able to refine and hone my existing power electronic experience and add, better power electronic simulation, circuit simulation, and LT Spice skills to my skill and software stack. So this is LT Spice. In addition to that, picking up a premium software like Altium. This is Altium Designer here, where it's one of the PCB design softwares out there. Really, it's I think the most popular PCB design software, where you get that flyback and you can import it or build it from scratch and put it into your schematic. See these circuits and electronics? This is real world stuff. So then you put that into a PCB form. Look at this. You get drafting skills. You start to value the aesthetics more. Maybe you already like art and aesthetics, and then it's an opportunity for you to apply that and, produce your own piece of work here. Let me show you the 3D model view, right? And you upload this to an online environment, which I'll talk about later. All right. So that's another skill. Another skill you develop is product management, product lifecycle management as well, and project management. You add that into software like ClickUp. I use ClickUp to keep track of my tasks and to make sure I am on task for what I need to do and things that are overdue. Let's see, other skills that you pick up. There's just so many different things. Depending on the project you're working on, you might be picking up PCB simulation software, right? To signal integrity analysis software. So many different things you can use to solve problems, and we get back into electromagnetic field theory when it comes to printed circuit board design as well. So a lot of problem solving skills that you wouldn't otherwise think of. And I also see the connection in printed circuit boards, how they're just mini transmission lines, and the power lines above our heads and everything, those are big transmission lines. Everything is transmission lines. It pretty much printed circuit boards design brought all of electrical engineering full circle for me as an electrical and electronics engineer, because I went to school for both. The power system subdiscipline and also the electronics subdiscipline, power electronics, power systems, control systems, and digital design. Okay. So yeah, the second reason is that it improves your problem solving skills and gives you more tools to work with as an electrical and electronics engineer. I know so many different software now, learning hardware and PCB design. Now let's get back into the game now that I've been able to reset and clear my head, see if we can get some wins. So not only do you expand your ability to solve problems from a practical kind of like, I want to say technician sort of perspective or way, you can actually boost your career opportunities. So this is the biggest benefit, I would say. You get more versatile. All right. So finally, PCB design makes you more versatile as an electrical engineer. Let me tell you why. So whether you end up in designing circuits like I've done before, power electronics, managing projects like I do at my current company, or working closely with other engineering disciplines like I did at Canon, having the skill set of PCB design opens up a ton more opportunities as an electrical engineer. It also helps you communicate better with your team. So what am I talking about? Well, when I was working at Canon, at JITX and whatnot, I was able to just be that glue that tied everything together, because I knew the electronics, hardware design side, the PCB design and layout side, while they knew the embedded code and the systems. I was also able to work with the mechanical engineer to say, oh, we need to have the PCB be this size or components be this height or something. And this is true. This is that true interdisciplinary experience that a lot of jobs ask for. So if you're, say, a student wondering, how can I get interdisciplinary experience, having PCB design, since almost every electronic product is going to have a PCB in it, you're going to be working with other engineers, embedded software engineers, mechanical design engineers, product managers, product designers, graphic designers. Okay, so if you look at the graphics on this controller, right, you had to have a graphics team. Maybe they're using Adobe Illustrator, Photoshop, whatever the case may be. And then you had mechanical engineers who were using Fusion 360 for the 3D model of the controller. What else? Let me see. You have product managers who have to manage the budget and say, oh, we can only get these components from these manufacturers. As a PCB designer, the hardware engineer who knows all of that stuff and where to source the components and everything, that's just absolutely vital and critical. You become the glue and are a true interdisciplinary engineer working with other engineers. Okay, so it's kind of like in Street Fighter, you know how to do your combos, you know how to do your let me see, special moves, your normal moves and all that stuff, and bringing them all together. All these things are like different parts of the team that make the entire a thing called gameplay, or being able to move or progress forward in the game despite challenging opponents. Okay, maybe not the best analogy, but I hope you kind of get what I mean. It makes a team really a team if you could work with the team in an interdisciplinary way. Whereas let's say you didn't know PCB design, right, and you could only do power systems, then you're limited to power systems. Or you could only do hardware testing and validation, then you only could do hardware testing and validation, and your salary is capped. Okay, so I'm telling you, when it comes to versatility, PCB design is at least one of those skills, one of those infinity stones, as one of my clients called it. Austin Ma. I'll link him below. He's a creative electrical engineer who does short form content. Very entertaining for short form content. And he called PCB design one of the EE infinity stones that an electrical engineer must have or pick up in order to become a well-rounded EE. All right. So yeah, I mean, you're definitely going to boost your career opportunities. And what about pay, right? That's another thing. Well, let me tell you this. When I went from just doing power systems engineering to be able to design PCBs for industry, it bumped my salary initially by $20,000. $20,000. Okay? 20K. And then every year or two after that, I'd get bumped by another 10 to 20K. So I'm telling you, when you add PCB and hardware design to your skill stack, I'm telling you, you're gonna be able to break past certain barriers, certain ceilings, because you have that skill. Now, of course, you'll have to exercise it and be at least interested enough in PCB design. It doesn't need to be the end all be all, but if you want to bump in that salary and the money you're earning, take a look at hardware design and PCB design. So I paused the game here. Let me give you a practical example of what I'm talking about when it comes to interdisciplinary experience, your career opportunities and whatnot. So let's take this arcade stick, for example. I got a custom PCB inside this stick, and every time I play, I'm relying on precise design work to make sure it performs perfectly under pressure, like when I was playing against Kimberly just now and trying to win against Altium. This thing has taken a lot of beating, and it's not just the theoretical electronic stuff, it's the mechanical aspects, the shaking, the thermal considerations, making sure that this thing is FCC approved. So if you look on the back here, there are labels. There's CE certification, FCC, right? This is something you get from successful electromagnetic compatibility and electromagnetic interference testing, things that you're not going to pick up in university, even if you get PCB design education. On the rare chance you do get that, you're typically not going to be hearing about EMC and EMI. So PCB design opens up a whole other world, and you're working with your interdisciplinary teams, your mechanical engineer, finding out what components and what dimensions the PCB has to be able to fit inside the arcade stick, right? Getting certification and testing, working with hardware test engineers, working with embedded coders and programmers to make sure this functions properly and has near zero latency, okay, and delay when you want to when you're transmitting your signals to your game. All right, so there's a whole heap of stuff, and PCB design plays a crucial role in team collaboration. Speaking of collaboration, let me show you practically what this would look like, right? So if I were to pull up this thing called Altium 365, this is a cloud-based ecosystem where you can upload your designs, right? And you as the PCB designer, you would upload your project to your workspace. Now, if you want a workspace just like this, then the link is in the description below. It's the first link. But what does this do? This allows you to upload your projects, and you don't need to have it done in Altium. So let's say you have a design you did in KiCAD, Eagle, Autodesk, in Fusion or whatever, OrCAD. See, I uploaded this project straight from OrCAD. And when I upload it, anyone on the team is able to look at my design, my schematic. So let's say this were the PCB for this arcade stick. Other people on the team, like mechanical engineer, can say, oh, well, you got this part, it seems a little too tall, or for this little bit of space we have inside of this stick, inside of the enclosure for this stick. And then speaking of enclosures, right, not only do you have access to the PCB, your team members have access to look at this PCB in the schematic. They can also look at, check this out, the MCAD co-designer ecosystem or environment. This is where you have your enclosures added to, you would download the plugin for your MCAD and ECAD software tool or whatever, and then you would have the enclosure pull up, and then you can upload your project and it'll show the enclosure around your PCB as well. And then you can make comments in real time. Anybody can go in here, procurement, sourcing, project manager, product manager, mechanical engineer, whoever, and say, oh, well, we need to change this or swap this out, or we had some issue and callbacks, and it seems to be this component that needs to be swapped. And then you as a PCB designer say, oh, okay, got you. I'm going to change that in the electrical schematic. So this is truly interdisciplinary software and a good modern approach to PCB design product development. So check that out, Altium 365. I think this is the only software doing this when it comes to true interdisciplinary work that makes it easy and not a headache. So, PCB design has definitely played a huge role in the trajectory of where I've been able to come and go as far as an electrical engineer. Now, with PCB design as a skill under my belt, I can get into the same spaces and ecosystems as embedded hardware engineers, software engineers and developers who do not have, say, the expertise to develop high-speed printed circuit boards, right, for instance, and so that's what PCB design has allowed me to do. So now, as I transition more into computer software development and whatnot, maybe game development, and also data science and AI, having this PCB design knowledge and skill allows me to fall back on something that is the physical, more hardware, so I can integrate those other disciplines into my engineering tech stack. All right. So, whether you're designing the next big tech product, or you just want to understand how, wow, Kimberly's really hard, or you understand your gaming gear better so you can know how to execute these moves, which is like really hard right now. PCB design is a must-have skill for any electrical engineer. So, let me know your thoughts in the comment section below. Do you agree that PCB design is essential? And don't forget to like, share, and subscribe for more tech insights and gameplay. Let's keep leveling up together, and I'll see you in the next video.